Second part of 9.1, looking at example 4, and I just real quick wanted to talk about this. It's called rationalizing the denominator. We talked about in the first video how you can't have a radical in the denominator, right? You can't have that square root sign in the denominator of your fraction for it to be simplest radical form. So let's take a look at what do we have to do to get rid of that. So we're rationalizing the denominator here. Let's say that we have uh, the square root of 7 over the square root of 3. Okay, we can't take the square root of 3. It's not a perfect square. So what we have to do is we have to rationalize it. What we mean by rationalize is we need to get rid of that square root sign, because the square root, if we type that in the calculator, it's going to be irrational. It's going to go on and on forever and ever, not ending, not repeating. So we got to make it rational. So what we're going to do is if we take the square root of 3 times the square root of 3, the square root of 3 times the square root of 3. Well, the square root of 3 times the square root of 3 is the square root of 9. The square root of 9 is 3. So root 3 times root 3 is going to give me 3, right? Root 3 times root 3 is the square root of 9. Square root of 9 is 3. Anytime you have the root of a number times the root of the same number, that number is your answer. So root 5 times root 5 is 5. Root 11 times root 11 is 11. Right? It's going to continue like that no matter what number you have under there. But whatever you do to the bottom, we got to do the same thing to the top. So I'm not going to multiply the top by root 7. That wouldn't make sense, okay? Because that's not the same thing. I got to multiply by the exact same thing, top and bottom. So on the bottom, it's square root of 3. So the top, I'm multiplying by the square root of 3. Okay, this is rationalizing the denominator. Take whatever the square root in the denominator is and multiply top and bottom by it. So root 3 times root 3 is 3. Root 7 times root 3, just like we split up numbers in the first part, we can put them back together now by multiplying and just keep it under the square root. So root 7 times root 3 is the square root of 21. Now there's nothing I can do with that. There's no simplest radical form for the square root of 21. So that right there is going to be my answer. Okay, let's try another one. Let's go, maybe I've got the square root of, let's say 18 over the square root of 2. Okay, let's say I've got that. Anytime you've got that denominator that is not a perfect square, then we multiply top and bottom by it. Okay, we multiply top and bottom by it. Square root of 2 times the square root of 2 is 2 on the bottom. 18 times 2 is 36 on top. Well, the square root of 36 is 6. So really what I'm looking at 6 divided by 2, which is 3. So we simplify it all the way down. Now this one wasn't a great example because if I do the square root of 18 over the square root of 2, I can combine that back together, right? I can combine that together to make it the square root of 18 over 2, which is the square root of 9, which is 3. So a couple different ways we can get there. Let me use an example out of the book here. That'll probably be better than me making up my own. Let's see. We've got I'm trying to find a specific one here, but it's not really working for us. Let's go basic. Okay, 1 over square root of 5. 1 over square root of 5. You got that square root of 5. Multiply top and bottom by it. Root 5 times root 5 is 5. On the top, I've got root 5. That's all I can do. Root 5 over 5, right? Root 10 over root 3. Can't take the square root of root 3, so multiply top and bottom by it. That's going to give me a 3 on the bottom, square root of 30 on top. No perfect square factors for the square root of 30, and we've got it. Now, if that top, after you multiply these two together, let's say that we were to get something that is a perfect square. All right, if we get something that is a perfect square there or has a perfect square factor, you got to simplify it. Okay, you got to simplify it, and you're going to run into that. Just know this is the process. Now, let's say that we have, we run into something that looks like this. Let's say we've got the square root of 3 over 2 root 5. Okay, so now when I rationalize the denominator, I only have to multiply by what's under the square root there in the denominator. the denominator square root. That's what I'm multiplying top and bottom by. So I'm ignoring the root 3, I'm ignoring the 2. All I need to do, I need to get rid of this square root here. So I'm going to multiply by just root 5, not 2 root 5, just root 5. Okay, just what's under the square root sign. So I'm going to multiply by root 5. Whenever I do the bottom, I got to do the top. That gives me root 15 on top. And then I got a 2 still there. And then root 5 times root 5 is 5. So now I've got 2 times 5 in the denominator. So that gives me root 15 over 10 for that answer. Again, can't simplify that anymore. Okay, so it just stays there, root 15 over 10. This is rationalizing the denominator. Now, example 5 in the book is going to be rationalizing the denominator using what they call conjugates. We're not doing that. Okay, that would be if there was an addition problem underneath. So it would be like root 15 over 2 plus root 5 or something like that. We're not going to worry about it. They'll teach you that in Algebra 2, I believe, but we're not going to touch it here. Okay, so this right here, this is all you need to be able to do for rationalize the denominator. Make sure whatever the square root is in the denominator, you're multiplying top and bottom by it. Okay, go back, watch it again. Watch the videos from the book. They might have a separate way of explaining it, but make sure that you're asking questions if you need some help on it.